As we all know, the planets in our solar system are very strange indeed, but now with hundreds of exoplanets being discovered outside of our solar system and even in other galaxies every single year, you have to wonder what are the extremes that these planets can go to, from the oldest to the youngest to the largest to the smallest, from the hottest to the coldest to the farthest to the closest. Here are the extremes of exoplanets. Let's start at the beginning of time, that is. The oldest exoplanet that we know of is called PSR B1620-26b, or otherwise known unofficially as the Methuselah or Genesis planet, as it formed about 12.7 billion years ago. When this planet came into existence, the universe was only 1 billion years old. Methuselah formed in a globular cluster, so it's likely the two stars that it orbits around now are not its original parent stars. Likely they were kicked out a long time ago and replaced with some others which have probably already been replaced several times already. Most planets in these globular clusters are planetless or planemos. This was also the first planet that we discovered which had more than one parent star. It's about 2.5 times the size of Jupiter, and it's unlikely that any life has ever been on this planet. Even if there had been, the pulsar would have eradicated any of it away with its deadly beams of light. On the opposite end of the spectrum, the youngest planet that we know of is a planet named Koku Tau 4, lying in the constellation of Taurus. It is another circumbinary planet like Methuselah, or it orbits two stars at once. These two stars have a band of gas and dust still surrounding them, meaning it's a very early solar system. Not much is known about this planet since it's surrounded in gas and dust from the disk that will later form its brother and sisters planets. But what we do know is that it's likely very large and rather gaseous like Jupiter, since it doesn't have any other competition for gas and dust to form it. Now let's hit a little closer to home. Literally, with Epsilon Eridani b, a planet orbiting the star Epsilon Eridani in the constellation of Eridanus the River. Even though it is only 10 light years away, we don't know much about this planet. It hasn't even been given an official name yet. The only thing we know is that it's the closest exoplanet that we've ever discovered to home. While Epsilon Eridani was a cosmic neighbor, this planet is hardly a neighbor at all, lying 3,300 light years away from Earth in the center of the Milky Way galaxy. Ogle 2005 BLG 390LB is the farthest extraterrestrial planet we have ever discovered from Earth. I'm not sure what that says more about, the size of the Milky Way galaxy or how far we are from the center. Either way, this isn't the only record that this planet holds. It is also the coldest extraterrestrial planet we've been able to predict the temperature of. It is so far away from its very cold, dim star that the surface temperature is likely minus 225 degrees Celsius, or only about 50 Kelvin. Spicing things up a little is Kepler 10b, the hottest extrasolar planet we've ever been able to predict the temperature of. It most likely started out its life with its sibling, Kepler 10c, as a rather far away planet from its star. It now orbits its planet in only 2 3/4 hours. This is because its previously rather reasonably sized star grew into a red giant, leading it to become so close to the surface of the star that it is constantly boiling away its atmosphere, blasting it out into space. The planet is losing its mass daily and may not exist in the next few million years. This also makes it the closest orbiting planet to its parent star that we know of. Its surface temperature is probably over 6,000 degrees Celsius or 7,143 degrees Kelvin. To put that into perspective, the element with the highest boiling point, rhenium, boils at over 5,000 degrees Celsius. Everything on this planet would be a gas. Now onto the planet with the shortest year, JMass J2126-8140. This planet takes over 1 million years to orbit its red dwarf parent star. Not much else is known about it, although it is very similar to Pictoris b, a nearby planet. Speaking of things that are big, HAT P32b is the largest extrasolar planet that we have discovered so far. It is over twice the size of Jupiter and only takes 2 days to complete its orbit around its sun, meaning that it is possibly the best case of a hot Jupiter planet that we have. On the other end of the spectrum, finding the smallest planet was a difficult chore, as most planet discovering techniques, which I may talk about in the future, favor larger planets as they are much easier to detect. However, in 2013, they were able to discover a planet called Kepler 37b, which was only just about the size of the Moon, in the constellation of Lyra. As you can tell, many extrasolar planets are very different, but I don't want you walking away from this with the wrong idea. Many, if not the vast majority of extrasolar planets, are hot Jupiters, Jupiter or larger sized planets that orbit their star in a couple days. But why are there so many of these? Well, this is because they're the biggest planets, which makes them easier to detect, for reasons that I'll talk about in the next video, and also for those same reasons. Stars that have planets that orbit very far away from them, those planets are also very hard to detect. But hopefully in the future we'll be able to take more time and care in discovering new, smaller, and farther away planets from their stars, like Pluto. So, until next time, this has been Science Freak Astronomy.